NRSC Dr. Prakash Chauhan, sir. Please join the lighting. Thank you, respected dignitaries. We now formally welcome our guest. We move to the presentation of floral bouquet. May I invite Dr. Vijay Lakshmi to come forward and present a floral bouquet to our esteemed chief guest, Dr. Ajit Kumar Mohanty, sir. Next, may I invite Ms. Priyanka to present a floral bouquet to our respected chairperson, Srimati Nirmala Balaji. And finally, I request Mrs. Sandhya once again, Mrs. Sandhya to present a floral bouquet to the director of the institute, Dr. K. Mrityunjay Reddy, sir. Thank you, Dr. Vijay Lakshmi, Mrs. Sandhya and Priyanka. To officially welcome all our revered guests and to set the tone for today's intellectual journey, may I now invite the Director of GP Bastry, Dr. K. Mrityunjay Reddy, sir, the dedicated organizer of this event, to the podium for his welcome address and a brief overview of the prestigious GP Birla Memorial Award.
A very warm welcome and good morning to all of you, the dignitaries and the dais, Sri Nirmala Birlaji, our chairperson, G.P. Bastry, G.P. Birla Archaeological Astronomical Scientific Research Institute, chief guest of today's function, Dr. Ajit Kumar Mohanty ji, Chairman, Atomic Energy Commission and Department of Atomic Energy Secretary. A warm welcome to all of you, sir. We also have 9 other eminent personalities with us today from the Department of Atomic Energy. And we also added another color jewel with us today, Dr. Prakash Chauhan, Director NRSA from ISRO. Welcome you all, sir. We are incredibly privileged to welcome Dr. Ajit Kumar Mohanty ji, a true visionary and a man of exceptional courage. Dr. Ajit Kumar Mohanty ji is renowned for his decisive action. Sir, your decisions are very prompt to the nation and we really applaud it, sir. And his eminence as a scientist is truly global. Dr. Mohanty is a highly accomplished nuclear physicist whose work spans critical areas from subcoulomb barrier to relativistic regimes. He has held pivotal roles, including director of the Baba Atomic Research Center, and has twice served as CERN Scientific Associate in Geneva, contributing to experiments like PENEX and CMS. His significant contributions have been recognized with the prestigious awards such as Homi Bhabha Science and Technology Award of the Department of Atomic Energy, and he is a fellow of Indian National Science Academy of Engineering. Dr. Mohanty ji, your journey is a powerful testament to what focused genius and selfless service can achieve. Over the decades, you have been commensurate, you are a cornerstone of India's nuclear infrastructure. Your career began and blossomed at the Baba Atomic Research Center, where you rose to lead the venerable institution before taking on the highest responsibility in the nation's atomic energy sector. As a renowned nuclear physicist, your contribution to high-energy nuclear reaction studies and detector development are globally recognized. But perhaps your most enduring impact lies in your quiet, visionary leadership. Sir, you guide a sector that is vital not just for the national security, but also for developmental goals, from clean energy and healthcare and advanced agriculture research. Sir, many people think that nuclear means atomic energy means something one side, but it has other various applications also that you are touching in all other facets. The peaceful and self-reliant harnessing of nuclear technology for the welfare of the common citizen remains the core mission of DIE, and under your stewardship, that mission is soaring to new heights. Sir, just to brief about this Shri G.P. Birla ji, he was the scion of the well-known Birla family. He managed and expanded the industries established by his renowned father Shri B.M. Birla ji, and as a result of his foresight and business acumen, established a large number of industrial undertakings in India and abroad. His positive vision, keen perspective, and progressive outlook made him one of the leading entrepreneurs in the country. Shri G.P. Birla ji was a philanthropist with a great vision, with a staunch belief and that industry was not just a source of wealth, but also means to improve the lives of community at large. He was associated with large educational, medical, research, and other charitable institutions. A significant part of his legacy lies in his cultural and religious contributions. In addition to establishing institutions like Birla Archaeological and Cultural Research Institute, now renamed as G.P. Birla Archaeological, Astronomical and Scientific Research Institute, and B.M. Birla Heart Research Center, he established several magnificent temples and science museums across the country. These include B.M. Birla Science and Technology Center, Jaipur, B.M. Birla Planetarium at Jaipur and Hyderabad, the Lord Venkateswara Temple at Hyderabad, Sri Lakshminarayan Temple at Bhopal and Jaipur, and our archaeological museums at Hyderabad and Bhopal. He also liberally supported renovations of places of historical, archaeological, religious importance with a view to preserve the cultural heritage of the country. In recognition of his outstanding contribution and services to the nation, Shri G.P. Birla ji was honored with the Padma Bhushan by Government of India in the year 2006. After Shri G.P. Birla ji, Srimati Nirmala Birla ji, a distinguished educationalist and philanthropist and wife of Shri Late Birla ji, is playing a pivotal role in carrying forward the vision of her husband and continues to uphold and nurture the institutions that were established with unwavering dedication. As chairperson of G.P. Basri, she has overseen initiatives in science, astronomy, and archaeology, attracting renowned scholars and Nobel laureates to this place. Her efforts in modernizing planetarium, curating rare collections, and launching of Space View with support of ISRO are transformative. The recent additions include Singarani Pavilion, sir, which you have seen just now, sir, with a Stegadon elephant tusk of 8,000 to 11 million years back history of India in Singarani Collieries, and a 75,000-year volcanic ash from the Mount Toba, which got erupted 75,000 years back, a dinosaurium that was established by GSI, and a map gallery recently established by Survey of India, which depicts 200 years old maps, and handwritten Constitution of India copy, and engravings of various old orders on copper plates, which were used by Survey of India for printing those days. And today's edition of NFC Gallery also reflects her dedication to innovation. We are eagerly looking forward to more collaborations with the Department of Atomic Energy to introduce many more such galleries to provide deeper insights of the scientific and technological developments of the country to students, young curious minds, and common public. Under her able guidance, we are exploring few additions to the institute, like Missile Gallery from DRDO, Earth Sciences and Ocean Applications Gallery from MOES INCOIS, and a Crystal Gallery from Ministry of Mines and Geology. Over the years, the Birla Science Center has been graced by the presence of 3 Prime Ministers, 1 President, and 2 Vice Presidents, and 32 Nobel laureates, and numerous governors, chief ministers, who have all served as esteemed chief guests to this same place, in the same auditorium. Shri G.P. Birla Memorial Award holds a significant place in our institution's history. The G.P. Birla Lifetime Achievement Award was instituted by Birla Institute, and later it was renamed as G.P. Birla Memorial Award in memory of Shri G.P. Birla's profound contributions. Sir, these awards have been bestowed upon 35 distinguished scientists so far. Past prominent scientists include 32 Nobel laureates, sir, and the Missile Man of India, Dr. APJ Abdul Kalam ji, former President of India, and the Satellite Man of India, Dr. Kastur Rangan, former Chairman ISRO and Secretary Department of Space, and the Cryogenic Engine Man of India, Dr. V. Narayanan, Chairman ISRO. Sir, now we have the privilege of having you here, sir. Sir, we, the Birla fraternity, are incredibly fortunate to have you with us today. The Birla Trust is deeply impressed by your unparalleled dedication and achievements and has unanimously decided to bestow this prestigious award upon you. I once again thank you for coming over here in spite of your hectic schedule and taking your valuable time for this memorable event. We would like to hear more from you, sir. And sir, just for your kind information, we have put this through YouTube. Many engineering colleges and institutes have been circulated. They all will be watching your lecture, sir. Thank you very much, sir.
Thank you, sir, for that insightful welcome and for providing us with the context and gravity of the G.P. Birla Memorial Award. The G.P. Birla Archaeological, Astronomical and Scientific Research Institute operates under the guiding hands of our respected chairperson, Srimati Nirmala Birla ji, whose vision sustains this platform. Srimati Birla ji has graciously asked Mr. Chetan to share a few words on her behalf. May I now invite Mr. Chetan to the podium for the chairperson's remarks.
Respected Dr. Ajit Kumar Mohanty, dignitaries on and off the dais and guests, on behalf of our chairperson, Srimati Nirmala Birla, I welcome you all to the G.P. Birla Memorial Lecture and Award Ceremony, an event dedicated to the celebrating the highest level of Indian scientific achievement. The award itself is not merely a prize. It is the recognition of vision, dedication, and relentless pursuit of knowledge that advances our nation. Today, we have the immense privilege of felicitating a leader whose work illuminates the future of India's strategic scientific domain, Dr. Ajit Kumar Mohanty, Chairperson of the Atomic Energy Commission and Secretary to the Government of India, Department of Atomic Energy. Dr. Mohanty, in your unwavering commitment to scientific excellence and indigenous innovation, you embody the very spirit of G.P. Birla Memorial Award. You have not just inherited legacy, you are actively building a stronger, brighter scientific future for India. On behalf of the G.P. Birla Archaeological, Astronomical and Scientific Research Institute, the entire Birla family, it is my deepest honor to present you G.P. Birla Memorial Award. Please accept this honor not just for your accomplishments to date, but as an encouragement for the immense work that still lies ahead. Thank you, Dr. Mohanty, for your service. Thank you all for being here.
Thank you, sir, for those gracious remarks. We now arrive at a pivotal moment in our ceremony. We are honored to officially introduce our chief guest, a figure whose distinguished service has significantly shaped the trajectory of India's scientific capabilities. To formally present our chief guest to the gathering and invite him to deliver the memorial lecture, may I invite Mr. Naveen Dubey to the podium.
Thank you, madam, for giving me the honor. It's my pleasure to introduce Dr. Ajit Kumar Mohanty, Chairman and Secretary DAE, whose contribution and achievements truly speaks for themselves. Let us take a moment to know more about our distinguished guest. Dr. A.K. Mohanty, born in 1959 at Odisha, is a well-known nuclear physicist, completed his bachelor degree in 1979 from MPC College, Barapada, and master's degree in physics in 1981 from Ravineshwar College, Cuttack, which was at that time under Utkal University, Bhubaneswar. Dr. Mohanty graduated from 26th batch of BRC Training School and joined Nuclear Physics Division of Baba Atomic Research Center in 1983 and got his PhD degree from Bombay University later on. He has taken over as a Secretary, Department of Atomic Energy, Government of India, and Chairman of Atomic Energy Commission in May 2023. Before his appointment as Secretary DAE, Dr. Mohanty has held the position of Director of Baba Atomic Research Center from March 2019 to September 2023, Director of Saha Institute of Nuclear Physics, Kolkata, from June 2015 to March 2019, and Director of Physics Group, BRC, from July 2018 to March 2019. During the past 4 decades, Dr. Mohanty has worked in several areas of nuclear physics, covering collision energy from sub-Coulomb barrier to relativistic regime. It includes experimental using peloton accelerators at TIFR Phoenix and CMS students at Brokenrev National Laboratory, USA and CERN Geneva, respectively. Dr. Mohanty has held several honorary positions. To name a few, he has served as a secretary and member secretary of BNS Basic Science Committee from 2004 to 2010, General Secretary of India Physics Association, IPA, from 2012 to 2016, and later on as a president of IPA from 2018 to 2020. India CMS spokesperson for CMS experiment at CERN Geneva from 2013 to 2015, and Dean Economics, Physical and Mathematical Science, BRC, Homi Bhabha National Institute. Dr. Mohanty has been recipient of several awards and recognition during his illustrious career. Some of Dr. Mohanty's awards and recognitions are Gold Medal in Graduation, Radha Govindan Trust Mayurbhanj in 1979, Young Scientist Award of Indian Physical Society, IPS Kolkata in 1988, Young Physicist Award by Indian National Science Academy, INSA, New Delhi in 1991, and DI Homi Bhabha Science and Technology Award in 2001 by Department of Atomic Energy, Mumbai. He has also conferred the CERN Scientific Association position at CERN Geneva from 2002 to 2004, and thereafter again from 2010 to 2011. He has received Doctor of Science from several universities. Dr. Mohanty is a fellow of National Academy of Sciences and Indian National Academy of Engineering. With all due respect, sir, I request you to please address the audience, sir. Sir, would you like to have color mark? Yes.
Color might help. So here it comes.
Sir, it is removed.
So here
Sir, this is pointer. So this is pointer.
and अच्छा इसमें
और ये नहीं, yes, sir. और ये सर ये डिस्प्ले वाला सर, ये pointer है.
So good morning to all of you. Honorable Madam Nirmala Birla ji, Dr. Reddy, Dr. Chauhan from ISRO, Mustansir sir, who is in the audience, and all dignitaries, and also my colleagues from Department of Atomic Energy, who have come here as Navaratna. I'm really proud of it because all of you could come here, and I'm very honored to give this memorial lecture because the way it is told, the predecessors, I don't stand anywhere near that. But in spite of that, you have called me. It is really, really an honor and fortunate. I'm fortunate enough to do so. And this is something I'll be talking, a work. Generally, now you know I'm heading the Department of Atomic Energy. 13 institutes, 18 are unit and 12 are granting institute. Those who do basic research, technology, like Tata Institute of Fundamental Research and Bhabha Atomic Research Center, and many things. We do everything. We do atom for the service of the nation. And I'm at this moment managing those things. But this talk, I'm going to talk something which I'm doing. I'm not going to tell which I'm doing, rather a talk which I'm not doing, because I did long back. That is something like 2012. I was party of some experiments, and based on that experiment, which I'll be talking about, it was related to the Higgs boson search, one of the experiment, what people call it God particle discoveries. And it was discovered in 4th, I remember, it is the 4th July 2012, experimental signature came. And later on it was analyzed, published, and based on which in 2013, 2 scientists got Nobel Prize for that. And that is the time I was partly leading this experiment. 13 to 15, I was a spokesperson of one of the experiment, which I'll be talking about. But based on this experiment, it gave the Nobel Prize. But this year, those who did the experiment, they got another prize called Breakthrough Prize. And in fact, Breakthrough Prize started in 2012. by a group of Russian scientists, businessmen, and the prize amount is 3 times more than the Nobel Prize. But Nobel Prize generally given by, generally they got 3 to 4 people, and it is $1 million roughly at this moment. But this experiment has done by 3,000 people, although it is the amount is $3 million. But then it is not the money, but it is the hard work. Because if that experiment was not done, probably that Nobel Prize would not have come. That's why my talk is a little bit about that experiment, what it was. And this talk I give in 2012 also, immediately when that Higgs boson discovered, as a public talk. And I have not changed the slides much. Some of my colleagues from BRC might have heard that. But I thought it is worth repeating because it got another prize. And the talks are such that my slides are basically collections which is existing in the public domains. In this experiment, the public took so much interest, they also started imagining how this discovery, what is this particle. So those slides are in the public domain. Like I'm visiting the museum, my talk will be slides. The slides are also, as you will find some of the scientific museums. And it is that type of talk only. So with this, let me proceed. I already told that there is a place called Geneva. In Geneva, it is a Switzerland, but there is an underground tunnel, 27 kilometer underground. And that experiment is a European experiment, and it is called CERN. It is a French acronym from European Nuclear Laboratory. And this experiment was done, and there are 4 experiments. The names are like this: ATLAS, CMS, ALICE, and LSC. But Indian collaborations are involved in 2 experiments, CMS and ALICE. ALICE is another group, and CMS is one group where I was involved. And this 4 experiment got this breakthrough prize for their experimental work. ATLAS, CMS, they discovered Higgs boson in that experiment. So they got $1 million prize each. ALICE and one out of 4, this is 3 million, 1 each, ATLAS and CMS, and $500,000 ALICE and LSCB. So this is how the whole experiment is. And you see, it is a big collaboration, I told you. A lot of Indian institutes are there. Like ALICE collaboration, you will see left-hand side. 16 institutes are there. The red one, VCC Kolkata, Shah Institute Kolkata, IOP Bhubaneswar. And CMS experiment, probably today, 22 institutes, Indian institutes are there. And the red one, BRC, NICER, SNP, TIFR. So these reds I have highlighted because they belong to Department of Atomic Energy. And the remaining are the IITs and other universities, but it is a completely Indian collaboration in that experiment. And this is what I have shown, that how the Department of Atomic Energy looks. I have already told that there are 17 plus 12 different units. In Hyderabad itself, we have several of them. We have NFC. NFC, somewhere it will be written in my NFC. We have ECIL. We have Second Center of Hyderabad. We have NCCM. Then we have Atomic Energy, AMC. We have AMDR, Hyderabad. And other units also. Okay, so this is what I'm talking about. 2013, 12, this discovery was done. In 2000, these 2 gentlemen, Peter Higgs and Francois Englert, parallelly, almost parallelly, they gave the theory in 1964 that there has to be a particle, what is called Higgs boson. It is named after the scientist Higgs. But later on, people told it a God particle also. I will tell you why it was told. And both gave the theory. And 1964, it was discovered almost after 50 years in 2012. And this is, I'll tell what is this experiment, why so important. It is supposed to give mass to all of us. Otherwise, you would have been massless, weightless, meaningless. The Peter Higgs, what happened? Theory came in 1964, and he is another Nobel laureate, Leon Lederman, and he wrote a book. The book is like this: If universe is the answer, what is the question? 1963, and it is about discovering that Higgs particle, which this gentleman has postulated. And it was so difficult to detect. And the book he wrote out of frustration, goddamn particle. and the editor of the book did not like the damn word. He deleted it. Book is published as a God particle. That is how the Higgs boson book became a God particle, and to the common people it is known as the God particle. So much so that people think CERN is a pilgrimage. And as I told you, this discovery took 50 years and a lot of funding, 24 countries, 24 states, European states, 10 associate members like India, etc. And 100 countries were participating in this experiment, nearly 6,000 to 7,000 scientists and engineers. And it was so difficult for 50 years it took after this theory. People also became quite interested because this theory is very, very important. It is thought that as we first landed in the moon as important, this discovery was also equally important. Otherwise, science would not have stand where it is today. And so as a result, what happened? The public also became very interested. I have written one paragraph here. This experiment looks like it is like a PPP model experiment, public-private partnership, which we are talking about today. The God particle has escaped detection for nearly 50 years. The delay is so much so that not only the scientists and engineers, but also the common men have started searching for Higgs boson. Even they have started helping scientists by explaining how this God particle looks like, how one should behave with it if you find, and also suggesting methods how to catch it. As I proceed in my talk, I will be showing you a couple of slides taken from the public pool, which are designed by common men through their curiosity-driven imagination. Therefore, if you find some of the slides you have seen elsewhere, it is my apology for this small repetition. And definitely those who are from BRC, they might have seen these slides because I gave this public talk in 2012. I told you that 4th July this particle was detected in an experimental laboratory, and it is a particle, after creation it never stays, it decays into the particle. So various charged particle or neutral particle, it will create a track in the detector, and there will be enormous tracks of this particle and other particles also. So you have to really, from the data, you have to analyze using all sophisticated mechanism. And according to the CMS scientist, this is an event which online they detected immediately. A lot of tracks are there, you can see that. And 2 particles are coming out. That supposed to be the signature of that Higgs boson created. It has come out in form of sub-particle. It is more analysis. I will be explaining later on. But to the scientist, this is an important online catch of that experiment by which they can say Higgs particle has been created. And this one went to the social media and became viral on 4th July. Later on, what happened? A real event display which contains the God particle. On 7th July, after 3 days, something came in newspaper. When I was preparing to give this public talk, one of my friends gave me this newspaper cut piece. I put in my talk. It says, temple built for Higgs boson God particle, Tamil Nadu, devotees throng to get darshan. Arti being performed for Lord Higgs boson. Public have requested the government to subsidize the annual pilgrimage of devotees to CERN. Where is this? Headquarters to pay homage at the Large Hadron Collider, where the Lord's divine presence was first detected. To this discovery, there is also another god is associated. I visited the museum. I saw that Nataraj. It is a particular dense form of Lord Shiva. Shiva is considered as the 3, Lord Brahma, Vishnu, Maheshwar, and this is a Tandava of Maheshwar. It is supposed to be a destroyer of the universe. Brahma is the creator, Vishnu is he looks after it, and this form is supposed to be the destroyer of the universe. But this is the real photograph which you will find in Geneva and CERN. It is donated by Government of India probably in the year 2004. It is supposed to be the supreme cosmic dancer, this form of the God, Lord Shivaji, omnipresent, embodiment of all virtues, the creator of this cosmic universe. And it was donated by Department of Atomic Energy. Today also we visit, it is a tall statue, you will see that. But this photograph was published in the public media again and again for the wrong reason, around the same time when this experiment is supposed to start at CERN, 2018. 2008, 2012 it was completed the experiment, but the accelerator started in 2008. Since then, people have been watching, it has gone to the media. For this one, for the wrong reason. For example, in Hindustan Times, 10 September 2008, it says, Shiva the Destroyer will preside over the Big Bang mock-up experiment. All as scientists at the European Organization of Nuclear Research, CERN, near Geneva, smashed subatomic particles in the world's largest experiment, Shiva, the Destroyer, will be the close proximity. On Wednesday, that is the Wednesday, 10 September, a powerful particle accelerator will use massive energy surges to simulate the universe creation with the Big Bang. Not only that, believe me, around that time, according to some, this giant machine is so powerful that it could create mini black holes that would goggle up more and more Earth's matter until we and our Mother Earth are fully consumed. Believe it or not, some people genuinely think this might happen and even have filed lawsuits in American and European courts to stop this device being turned on. And these are the real facts. And I don't know whether it will move here. I have an animation taken from the, no, it is not moving. Okay, this is the animation, it doesn't matter. Okay, so not only this, you must have heard a book by Angels and Demons. It is written by Dan Brown. It is one of the best sellers in 2000, and there is a movie based on that in 2009. This is the fiction movie, fiction book. Movie is also fiction. And the author here, he also talks about matter and antimatter. And he says, what is matter, what is antimatter, what its property, and where it to use it. And he says the people at CERN, by experiment, going to create antimatter. And he gives prescription, if it is created, where you can use it in this book. So his theory about, based on CERN experiment, matter versus antimatter, he says there are Tom Hanks and there is anti-Tom Hanks. They look very much similar, but they don't like each other. And when they come together, when they meet, they will annihilate into energy, E is equal to mc square. And he says the Large Hadron Collider at CERN, Geneva, will produce antimatter, which will be used as a bomb to destroy Vatican. Well, what I am telling you, see, until it is discovered how much public has participated in this design, some slides I will show later on also, but nothing has happened. It has been discovered. People are excited. Whatever we had the fear that time, definitely very soon converted into confidence, and trust has been built up so much that people now are ready to worship this discovery. The question is, what was this big discovery and where this pilgrimage is? The machine name is called Large Hadron Collider. Large means it is a tunnel of 27 kilometer circumference underground. 100 meter below the ground, 27 kilometer tunnel. So it is a large. Hadron means inside that proton moves. Proton means, you know, that hydrogen atom. It has one proton as a nucleus and outside is the electron. If you take out that electron, you know what it does. You can ionize it, then what remains is the proton. It is a hydrogen nucleus basically. So that moves. The name of the proton in scientific term is also called hadron. So large hadron, and it moves in the tunnel. One proton will go one way, clockwise, another is anti-clockwise. So they will collide. So it is a Large Hadron Collider. And this is what a French acronym of CERN. In English it would mean European Organization of Nuclear Research, I told little before. And 24 member states are there all over the countries. These are the European countries. 10 associate members, non-European. India is one of them. And users, if you see, close to 8,000 to 9,000 people are working. And this is the place. You can see the tip here at the end. Here, this is the place called Geneva. This is Switzerland, and it is France. So this machine is 27 kilometers, 1/3 in Switzerland and 2/3 in France. And this is where the tunnel is, and proton moves like this, one side, and also another side will come in other side. But this is the surface view, but actually below the ground, this is how it will look like. If you go down, the tunnel is actually the circle one, 100 meter down from the surface, and the particle proton, it accelerated due to the electromagnetic cavity. It will accelerate, it will gain energy, so it will move almost speed of light, and magnets are there to bend it, so it will move in the circle. And this is the tunnel. You can say person can move, it can move, so this is the tunnel, 27 kilometer, and the best athlete will take about 1 hour to complete the tunnel. Whereas the proton, which will move, it will take 1/10,000 seconds for a proton, very, very fast. So this is the speed proton will be moving. And inside the tunnel, there are these are the tubes, inside which proton will go, completely vacuum. And there are devices to accelerate the proton and also bend into the tunnel. These are the sketchy words I am talking, not going into detail. And then what happened in a large hadron collider? One proton comes this side, another this side, at a very high energy. The energy in scientific terminology we call tera electron volt. Electron volt, you know, 1 electron energy. If we have a 1 volt battery and 1 electron moves, the energy gain is electron volt. But now you imagine 10 to the power 12 electron volt, 1 into 10 into 0.0000012 electron volt, huge amount of energy. You cannot create ordinarily except a accelerator, and in that energy, what we call tera electron volt, if two protons comes together, something very unusual happens, which we are going to study it. Something like this will happen. Many particles will come out, and a Higgs boson, which I am talking about, should have come out of this. This is what that experiment is. Before that, let me see what was this big experiment. What is the meaning and purpose of this experiment? It involves more than 100 countries, as I told, more than 10,000 scientists and engineers, took 20 years to build over a length of 27 kilometers and 3.8 meter width a tunnel. And cost is very costly that time. Now it would have gone up. It is the estimate of 2012. Technological innovations. Building is not just a tunnel. Making the technology was an innovation itself. 1 or 2 slides I might show how that innovation has become so popular, people even don't remember that innovation. I'll tell that. Why? Why such a big question? Why we are doing such a costly experiment? We want to study something very fundamental constituent of matter. We say everything is made up of matter, atom, nucleus, but beyond that also you want to go. What is the origin of mass? Everything you say, I'll spend little time on the mass. We have a mass. We can determine by using kg, kilogram or something, but how that mass came? Even scientists can ask a question, what is dark matter, dark energy? Maybe a little bit I'll tell. And is there any extra dimension? We live in 3 dimensions, x, y, z. Time is another dimension, but people believe probably dimension is more than 3 and 4. Lord Shiva has more dimension. If he closes 2 eyes, he can see something more. So there are more dimensions in our mythology also. In reality, people believe science, there could be more than 4 dimensions if time is 1. Here are the issues. Newton, we know. Newton predicted mass and weight. If mass is meaningless if there is no gravity. And the moment you associate gravity to that, you will express that as a weight. Our weight in moon is 1/6 time less than our weight in earth because we have a more stronger gravity. So that is what Newtonian phenomena. Einstein, you know, great person, E is equal to mc square, he told, mass can convert it to energy and vice versa. But neither of them explained what is the origin of that mass. Who gives that mass which can convert it to energy? And this was the question. For example, electron, very tiny object. It is almost massless, you can say. But even then it has a mass, 10 to the power minus 31 kg. Very, very, very small, minus 31. 1 divided by 10 to the power 0.000 up to 31 places. You cannot imagine the mass. But it is meaningful. And in terms of energy, it is 0.5 MeV, million electron volt. So who gave the mass? Electron, when the universe was created, electron was massless. It was a radiation. But it became mass after some transition. And then what is the transition? Who give the mass about this theory? By some mechanism, mass has been created. It was not, God has not created mass. A mechanism has created mass. That is what the study of this experiment. Are masses of elementary particle due to interaction with the invisible Higgs field. Since the scientist Higgs proposed, is named after him, there is an invisible field interacting with that. All particles, those who are massless, got mass. That is the mechanism. And in this process, one more particle was also created, that is Higgs boson. And this is all, it is called in scientific term, excitation of that Higgs field, creating that particle. And these are going into the detail of the science. I will not go. But note that this question people have not asked. Ancient people have asked ourselves, what is the composition of us? Some people say everything, even ancient Greeks philosophy, they say earth, air, fire, water. Four elements. We are composed of 4 elements: air, water, earth, fire. And Panch Tattva, Hindu philosophy, we have added Akash. So we call Panch Tattva. Khit, Jal, Pavak, Gagan, Shamir. So these questions people are asking since time immemorial. What we see, what around surroundings, we question ourselves what is made up of. But this is how science has developed, and it developed much more. By 1900, we knew 100 elements. Mendeleev's periodic table, if you see, 2019 it completed 150 years. The elements are gradually discovered. By 1900, we have nearly 100 elements. And all elements, we are composed of all elements in a higher level. And by 1936, not only element went down, and we had proton, neutron, and electron. So now typically if you say it is an atom, inside the atom there are nucleus, you know. Nucleus is composed of proton and neutron, and outside it is electron. And this is all you know probably. And this is the sketchy picture of periodic table which Mendeleev told. Hydrogen, helium, lithium, beryllium, like this it is arranged. And this is what the model by then, if you see at the center there is a red dot, that is the nucleus. And outside there are electron moving. Helium is one example. In helium there are 2 electrons, and there will be a nucleus. Neon there are also 10. I have shown only 4, but these are outside. This all a neon atom or a helium atom, and all atoms will be an element. This is known up to 1900. Rutherford came in the experiment. You know how many in the school you must have studied. Rutherford did an alpha scattering. It is a helium nucleus experiment on a gold foil. He said these alpha particles, when hitting the gold foil, they are not penetrating. So the nucleus is not hollow. It is having something by which it is reflecting. So this is what famous Rutherford scattering. And he concluded that nucleus, which I told that it has a neutron proton, he only concluded, Rutherford discovered nucleus is made up of protons, which is a charged particle, which are positively charged, and neutrons, which have no charge. And that is what the learning is. But the question arises, does nucleus has also structure? If nucleus means neutron, proton, do have further is it possible to subdivide them? As I told, 1936, we knew about 3 particles, electron, proton, and neutron. Question is, each proton or neutron has structure. Is there fundamental, or if you divide by some mechanism, again you will see something more? Answer is yes. And what we call that inside every neutron proton, there are quarks. I don't know how many of you have heard quarks. There are 6 types of quarks: up, down, charm, button, charm, up, down, charm, beauty, top, bottom. These are technical names, but our nucleus is made up of 2 of them, up and down. You can see the symbol U and D. Proton is made up of 2 U quarks and 1 down quark. Neutron is 2 down quark, 1 up quark, and electron. These are all fundamentals. You cannot divide them from electron. You cannot divide. Quarks you cannot divide. These are the real fundamental particles, and they are held by nuclear force. Some people say they are held by gluons, like a photon or light. Electromagnetic radiation, in between there are photons, a medium of interaction. Gluon is the medium of interaction for quarks. That is how everything is made up of. This you knew. Question is, why Rutherford could not do it? He told that nucleus is proton, neutron. Why didn't find quarks? He could have also told proton, neutron has a substructure. The reason is as follows. Why Rutherford did not predict quarks? It took a long time. Gell-Mann did it. much later. The issue is he theoretically predicted, experimentally proved afterwards. See, in science, we say we have to do an experiment with higher resolution. What does it mean? One needs experimental probes smaller than what you are probing. If you are probing a size of this much, your probe should be smaller than that. And this is the whole story of this science. For example, as I told, I have taken example from some fiction, some people's participation, because this science is like that, and this is in public domain, you will get it. Here is a dark cave. A fellow has fallen into that, and he has only glowing balls, and he doesn't know what to do. It is a cave and dark. So he has to do some experiment to know where he is, where are openings, whether the cave is infinite or there is a boundary. So what he could have done, if you have a that glowing balls, you will just throw it. If it is empty, space is empty, it will pass through. It will not bounce back. But if there is an obstacle or something, it will bounce back. From there, tracking, I am using the same word tracking which scientists do in the modern physics. Same tracking, probably he can say that something he can conclude like this. Suppose he started throwing dark cave with glowing balls. If he throw those balls all over, if there is an obstacle, it will come back, and remaining it will pass through. Wherever it comes back, knowing the track, how it comes, he can make out something that, oh well, the object, around this region there is an obstacle of this shape roughly. But he cannot say what exactly this obstacle is. Then next thing is, he will make the ball small. If the makes, instead of this, make the ball small, what will happen? Can you guess now, any of you? Same object will appear you slightly different, like this. He will tell, oh, it is a bear. There is a bear somewhere. It is not only obstacle, there is an animal. What he did, just he improved his measurement, resolution of the measurement is improved. Exactly same things we do in science. What we do? We increase the particle which will be probing, we increase its energy. Because you see, I was telling a little bit, I have done for some school children, that if a 1 volt battery and you put an electron, it will accelerate. And the energy is 1 electron volt. But this electron volt is nothing but the kinetic energy gained by an electron when it accelerates through an electrostatic potential of 1 volt. So that is called 1 electron volt. You can express in joule also. If you increase 1000 times, you will call kilo electron volt. If you increase another 1000 times, it will call mega electron volt. If you increase another 1000, you will call giga, another 1000 tera. The experiment which I will be talking need energy of this 1000 of the tera electron volt. 7 tera electron volt of this experiment which was conducted. How to get this? You cannot use battery or any accelerator. You have to have, you cannot use a normal electrostatic or any even Van de Graaff type of machine will not work. You have to have a cavity, RF cavities, radio frequency cavities or cyclotron in certain form. Okay, something has eaten. So this cyclotron will use to gain the energy. And what happened? When you increase the energy, particle energy increases, momentum increases. And when the momentum increases, you know every particle, fundamental particle, even proton you will do that, momentum increases, the associated wavelength, we can, little scientific I am telling, lambda is equal to h by p. If momentum increases, wavelength decreases. So when energy increases, size of the particle or the wave at which you will be probing becomes smaller and smaller. And this energy, it is so small, it can probe the tiniest size of the atom. That is the philosophy. And what happens when you do that? I am giving a very simple terminology I am explaining. These are 2 aeroplanes, or you think, and I am increasing their velocity using an accelerator. When they come and hit, well, it will break into pieces. No, you will not get any meaning out of it. It is just broken, accident happens. Okay, I repeat this. I increase the, again energy, come with high. You will see smaller pieces. Well, something different happened. Still I increase. You will see something different has come out. E is equal to mc square. From that collision, something has come out which was not there before. The collision energy was used to create something new that didn't exist but does not anymore. So this is the dinosaurs created. And again you increase. These 2 dinosaurs will created and that decay immediately. The interesting thing is the dinosaurs disappear almost instantly. So if Higgs boson is created by such mechanism, it will decay instantly, lifetime is very, very small. So we see the resulting particles. So we have to be like detectives, look at the evidence to see what happened. So even the Higgs boson, if you created, it will instantly decay, but it will leave the traces of the particles, which will create a track in your detectors, measure them, estimate the energy, like a detective find out what would have been the original particle mass, etc. This is whole game all about. That's why the tunnel is increase the energy, create the particle. Particle after creation it would have vanished also, but the signature it left, analyze the data, and create it. That's why people looked this type of data, and where they said there could be Higgs boson, and these are the little scientifically Higgs boson left side, it will decay to 2 photons, 4 leptons, electrons or muon, or 2 electron, 2 photon, many things. From this channel, you reconstruct, find out the momentum energy and hypothesize, and you see something new has happened, like this particle was discovered. And this is more experimental, I will not go to here. And after which, 2012, paper was published, and these two gentlemen, those who have given the theory, they got the Nobel Prize. And in this experiment, I told you BRC, particularly CMS experiment, Delhi, Punjab, IIT Madras, NISER, many IITs, Bhubaneswar, IIT, ISER, Pune, these are all experimentalists. And from India, I told you that there are probably this experiment, this paper which is published in the physics letter, Higgs discovery, probably today it has around 14,000 citations. You can imagine in 12 years. Unamusing. No paper will have this much citation, one of the high citation. But then credit is shared, 3,000 authors. And out of that, maybe 70 will be from India, and maybe 10 people, 5 people will be from BRC. I used to be one of them. But then it is not to take in much credit. I told you, it is a collective. If anything, if science can develop collectively with harmony, this is one example. And this is the example I am telling. Individually, you will not have got anything. But collectively, you could get, it is like the Pancharatna you have seen, the single bird is not able to fly when he fall into a net. But collectively, they could fly. This is one such example. It is a collective science. 2 great men predicted, but not so great men of 3,000 of them put equal to 2 great men and got the breakthrough prize today. Why did it took so long, almost 50 years? What was the difficulties? I told you, innovation, technology and innovation was first of its kinds. It has several technological challenges and innovations. Just I will scale in a very simple way I can say, that pipe which you are showing, it has to be vacuum. Even a single atom of air should not be there, otherwise these particles will get absorbed, you will not see. Such a rare phenomena. So that tube has to be evacuated. Evacuated, can you imagine? 10 to the power minus 10 torr. Imagine for a moment, your atmospheric pressure is 760 torr. With respect to divide by 10 to the power 10, that small pressure. It is almost super vacuum. And that has to be achieved in this tubes where proton is moving. Not an easy job. We are doing it now. India is capable of it. This type of vacuum, RRCAT Indra can create, VCC can create, BRC can create. And we have mastered it. But these are the first time it is done. It is the coldest place in the galaxies. That tunnel I am showing, there are magnets which is bending the particle, charge particle. Coldest because it cannot be working in room temperature. These are electromagnets. When the electricity flows in the magnetic coil, there will be a lot of heat loss. You have to minimize the heat because magnetic power is very, very high standard magnetic power because such a moving particle is to be bent. And to create such a high magnetic fields, you reduced all the energy loss. It has to be cool almost temperature of liquid helium, that is 1.9 degree Kelvin or minus 271 degree centigrade. 0 degree centigrade you can know ice, but go minus 270. So that is the temperature they have achieved to operate those magnets. That's why we call it Large Hadron Collider is the coldest place in the galaxy. And this type of thing you have to achieve. Even cables, whatever cables goes, like 36 strands, each strand is exactly 0.825 millimeter in diameter, how thin you see. 6,300 superconducting filaments of niobium, titanium. This material itself is not available. Niobium, titanium, these are the critical minerals today. But you see, they have to have the distance cables, 1,200 tons of cables, which translates to around 7,600 kilometers of cable. So these are the requirements of that type of machine. First of its kinds. Naturally will take time. And what is the gain to the common man? Why should people fund it? There are many examples, but I will stop with the two. And the gain to the society is so much, probably you will not be remembering this gentleman. How many of you remember this gentleman? Without this discovery, probably life would have been meaningless today. Nobody knows. Anybody from children or school children? No. If I tell the name, somebody could guess. Tim Berners-Lee. See, this is the CERN. I told 100 countries are working, and travel is not that easy to go and work. Somebody thought, can I communicate through the internet or www? And this type of thought came by this gentleman. He's a CERN scientist. And this, as always we say, he's the inventor of World Wide Web, www. Things have changed today. Today we live in the digital medium. We live in the cyberspace. There is another space. We know Brahma, we know Prithvi, Akasha and Patal. Another space is called cyberspace today, for space. Human being has created another space we live, and this is the origin, www. And this was created because there was a need for it. He never thought that it will go to the society. He first thought it will be used for our purpose. That's what we call necessity is the mother of invention. There was a requirement. And today, it is, if you go to the CERN, very proudly they say that on 6th August 1991, the first website was born at CERN, Geneva. But today it's so popular, you may not be knowing the scientist. You may be knowing Vodafone, or you may be knowing a service provider, Airtel, and who gives high speed. But these are people not important to the society, but they are for the society. We would not have been today the way unless these people are there. This gentleman, Nobel Prize he got, Charpak. He developed a detector, multi-wire proportional counter, again to detect this charge particle, because there are so many particles. After detecting, then only we will study their property, what is their energy, momentum, mass. A detector is required, very sophisticated detector for this particle. But today, it is using for medical imaging. Like, I will not go to that, but this is all imaging system. If you see PET scan, it is also a tracking detector, which is used for hospitals, positron emission tomography, MRI. These are all nothing but contribution, a considerable contribution has come from scientists of this type. Contribution to the society is so significant that we quite often don't imagine that how it would have come and who would have contributed. That's why quite often we ask when you do some basic science, first time there is no answer why you are doing it. People ask what is the fun, why you are doing so expensive. But I tell to the people what is basic today, it is tomorrow, technology for tomorrow. You cannot ask this question today. If same question if you ask about the newborn baby, what is the use of this boy? What you will answer? After grown up, he can become saint or he can become a problem to the society. So there is no answer, but you have to do science. Something happens. Many times science experiments are negative, but many times they are positive. One positive, successful discovery can compensate n number of unsuccessful experiments. That is how we are today. I move on. Okay, I wanted to see many other examples of this type of basic research. Accelerators today, I showed an accelerator, but there are many types of accelerators which are using for medicine. Probably today I need not go, but just one example, if you see, people, I mentioned PET scanning, positron emission tomography. Everybody goes to the hospital, not everybody, those who suspect some malign character, they go to the hospital, and first is PET scanning. If there is a tumor-like behavior in anywhere, it is just PET scanning, but how many of you will be knowing, but those who do not know, it is basically, they take a glucose, fluorodeoxyglucose, it contains an element fluorine 18. You don't get in nature. It has to be created by using oxygen 18. And you use this proton from an accelerator with high energy. proton will react with oxygen 18, which naturally available with low concentration, and it became fluorine 18. It is a radioactive. And that fluorine 18 has a half-life of nearly 2 hours and decays with not electron, but decays with a positron. It is the charge particle. It is a antiparticle of electron, but this is what it happens. Fluorine 18 positron emitter. It is a proton plus oxygen it creates, and the medicine which is injected to the patient is flu deoxyglucose. It contains that fluorine 18, and it is used for, and it is absorbed in the body, that glucose. If it is a cancerous tissue, it absorbs more glucose than the normal tissue, and once it absorbs more, particularly this fluorine 18, it emits that radiation, positron. It comes up, and positron immediately annihilates with an electron nearby and gives two gamma rays. That comes out, and that is detected. And once you detect the gamma rays, how it is coming, connect to where it would have come, then that location in the body you can say, well, it has come from that location. Probably there is a tumor. This is what the principle of PET, but it is so common. Everybody knows PET, but nobody can expand what is PET. Positron emission tomography, not many, but everybody will learn PET scan. Because science has become day-to-day life. It is like a dish, normal dish today. Maybe something I am repeating, that little pictorial I am showing, fluorine, which is in that glucose. By the time it goes to that cancerous tissue, wherever it is absorbed, it gives E plus, that is a positron, and E minus electron is around, combines, and two gamma rays comes out, and that is how detected. Okay, fine. So let me just tell that all these discoveries we have completed. Last one was that Higgs particle. Now if you see, I saw the periodic table of Mendeleev. You have elements, uranium naturally occurring, hydrogen to uranium naturally occurring, and you can transmute. There are up to Z is equal to 116. Uranium is 92. Afterwards, people have created transmuted elements. This is the periodic table. But I am talking what is there down if you go. Electron, fundamental. Nucleus is proton, neutron. Proton, neutron is not fundamental. They are quarks. The left-hand side is showing a real atom now. Outside you can see there are electrons, fundamental. And that patchy inside, you can see that it is a helium atom probably. There are 4 proton, 4 neutron. And inside them you can see small quarks, U and D. So this is what the periodic table of elementary particles. It has, they are interacting depending on the reaction, etc. There are 4 types of forces. Strong force, nucleus interaction is strong. Electromagnetic, which light interacts or 2 charged particle interacts. Their medium interaction is photon. That is again a quanta of light. Gluon is the medium of strong force. Weak force, beta decay is a weak force. There are 2 particles, W and Z boson. I will not go. Gravitational also, gravity, something false. There is a gravitational force. These are 4. This part of this talk I am talking about, gravity is not part of it. Then we know quarks. There are 6 types of quarks, up, down, charm, strange, top, bottom. These are called quarks. 2 of them build the matter. And below this, if you see, they are called leptons. Electron is one of the lepton. It has 2 cousins, muon and tau. They are detected. Electron, muon, tau. These are like electron, they behave, but massive. And every electron, muon, tau, there is a neutrino. 3 types of neutrino. Very interesting particle, because when there is a beta decay, there is a neutrino comes out. Most abundant in the universe is light. Probably after light, neutrino is abundant. It is there time immemorial. Today you are sitting, lot of neutrino passing through your body. It doesn't interact, but it is there. So there are 3 types of neutrino: electron neutrino, mu neutrino, tau neutrino, and all those things have their counterpart, antiparticle. So whatever I am showing, these quarks and leptons, you will have an antiparticle also. Opposite electron, positron is antiparticle. These are the present understanding of these elementary particles. Which was not detected so far is this Higgs, which is sitting at the bottom. So these particles got mass from a Higgs field, and in this process, these particles became massive. I told electron is a tiny mass. This mass it got from that background such a field. Interacting with the field, they got the mass. And in this process, a Higgs particle was also created. That is what Higgs, which was detected in 2012. And all story I am talking about. Higgs was discovered in 2012. how does this elementary particle get mass? Then question arises, how then it gets mass? Because very difficult to explain. And well, if there is a field and electron or quarks were massless at some point of time when universe was created, at some point, as the temperature of the universe falls down, they start interacting in that field, and some point, some symmetry was broken, by which they got the mass. Probably I will not be talking the science here, except telling that this mechanism called Higgs mechanism, through spontaneous symmetry breaking, by which it got mass. And symmetry, a toy example I will give. What do you mean by symmetry? Look at this photograph. It is artist's imagination of this painting, perfectly symmetric. Left-right symmetry, left exactly looks like right, and in science we call it has a translational symmetry. If you replace x with minus x, it will remain same. But in reality, this is what is happened. God doesn't allow symmetry, it breaks symmetry. And what exists in reality, something like this. Nobody is perfect. So symmetry is broken in nature also. Artist's imagination has broken by the God. And when this symmetry is broken, it is a purpose. God has created in physical system also, symmetry breaks, but for a purpose. There are many examples, but I'll give one example which all you will aware. Magnets, ferromagnet and paramagnets. You know ferromagnets which attracts iron and magnet attracts. Hit that magnets, it will be demagnetized. No longer magnetic will happen. What we say, the ferromagnet become paramagnets at some temperature if you heat. So some state by which, basically in scientifically we say pin of the atoms. It was aligned certain way, it was behaving like a magnet. The moment you disturb that spin alignment, become disorder, it became paramagnet, symmetry broken, like this. Right hand side is a low temperature phenomena, which something is aligned, but when you hit it, it becomes misaligned. So symmetry breaks. And this happens in physical phenomena like ferromagnet to paramagnet. And this is something happens in Higgs mechanism also. Everything was symmetric at at high temperature. Below some temperature, symmetry breaks, they acquire mass. Before that, there was massless. Scientifically, it is a little complicated. They got Nobel Prize for this theory, not that easy to explain. They talk in the potential, they talk many things, T is equal to greater, I will not go. I am showing it again much complicated, you can say potential looks like this, it breaks. But then this is not good, because when this machine was built in 1990, around that, many countries contributed, including United Kingdom also. Prime Minister was Margaret Thatcher. She told that, their science minister, explained to him, why should we contribute such machine to have the Higgs mechanism and to understand how the Higgs particle was, God particle was created. Why should we contribute? If we have to contribute, somebody should explain me what is Higgs mechanism. How can you explain Higgs mechanism using this graph to a politicians? Very difficult. But then I told this is a field, public is so much interested. They have also come out with idea. What should be Higgs mechanism? And I'll tell you this. Imagine for a moment, it is a story, of course, you have to take a pinch of salt. See, if you say that it is very complicated without using the couple of mathematics equation, I cannot explain you, not true. Because there is a famous American physicist, Richard Feynman, you know, he says, he is an eloquent speaker, great communicator, of science communicator. He says, if you cannot explain your research to your grandmother, then you don't understand it yourself. And it is absolutely true. If you have understood, some way you will be able to communicate. And this is the communication you see. This is a cartoon, and it is an auditorium. These people, they are politicians waiting for somebody. Imagine this hall, dark, and suddenly switch off light. When it was dark, there was nothing, and when you switch off light, you will say it was filled of light. If I go a little deep inside that, I'll say it is filled of electromagnetic waves, visible electromagnetic waves. Again, if I want a little complicated, I can say it is not electromagnetic waves, it is full of photons, because electromagnetic waves you can quantize in terms of photons. You can say there are millions of photons roaming around this, massless photons. They are massless and moving in this hall. As a result, it is illuminated. Similarly here, the politicians are in a hall moving almost with the velocity of light because they don't have mass. Anyway, politicians do not have mass. So they are moving with the velocity of light. No, don't take it seriously. And when they are waiting none other than the British Prime Minister, Margaret Thatcher. She is coming with her own velocity. She has her own weight, own mass. But when he enters inside, what will happen? Imagine. This is the imagination of the cartoonist. As soon as she enters, people will be crowded her, try to garland her, and whatever she is moving, slightly her movement will come to slow down. So she will be collecting dust around her, and earlier she was massive, moving faster, now she became fatty, and she gained mass. So what they want to try, a particle which was massless coming with high speed, in this field by interaction become massive. This is the Higgs mechanism. These are the Higgs field, and that particle is Higgs. And this has happened in 2012, around that, or maybe a little before. And that time our Honorable Prime Minister was Manmohan Singh. I have replaced it with this. Well, I have almost come to an end. There are many such things I won't be repeating. But you know, what happened after so much discovery of 50 years, even the people got breakthrough prize, etc. You know, in Indian cinema, when all is well, it ends well. Otherwise, version 1, version 2, version 3 comes. Dabang 1, Dabang 2, Dabang 3, you must have seen. So, when all is not well, it doesn't end. This is exactly happened in our fundamentalism. And one such issue is neutrino. And that neutrino which I showed in that table, if you recall, such a beautiful theory, only the last particle was missing, Higgs boson. After so much effort, etc., was detected. But in this theory, the neutrino was supposed to be massless, zero, absolutely zero. And a beautiful theory based on which so discovery happened. But then later on, same group of scientists got Nobel Prize proving the neutrino has mass. It is a very tiny mass. But then it is a wonder how such a beautiful theory has not worked. It is not a deficiency of the theory, it has worked, but it is not fully understood. So this is how the science goes. And this neutrino, now effort is searching for neutrino, search its behavior, and it is one area going on. Big accelerators are being built now, not only to create this particle, but create interaction, protons such a high energy, which will interact, pions will produce, decay into many other things, including neutrinos. And those neutrinos generally don't interact, they will penetrate wherever you want. For example, CERN in Fermilab, they are having this neutrino missile, they will shoot. And on the other side near South Dakota, Dunes experiment will detect this neutrino. It can move millions. It can go from one planet to another planet. In fact, it is so difficult to detect. People sometimes call it is a ghost particle of the universe, because it's like a ghost present there, but you don't feel it. But it is telling you something, that I am here to tell probably the creation of the universe. God never creates anything meaninglessly. Probably this neutrino going to tell something to us which we have not understood yet. And efforts are there. We have not succeeded. We wanted to make a neutrino observatory in Badi, South Tamil Nadu, Badi Hills, because it is such a tiny, non-interacting particle. You want to go down and down to eliminate background, 1 kilometer down the rock. But various political reasons, otherwise also, we have not succeeded yet. But I am telling to my colleagues, why you have to look cosmic, muon coming from the cosmic origin. We missed something, like this neutrino was discovered in the reactors. Nuclear reactors have plenty of them. You know, when fission happens, when uranium splits, neutron is produced successively. 2.2 to 3 neutrons produced, not in one go. It is a series until the fission fragments get equilibrated. They go by the beta decays, neutron emission, and there is a beta decay. Each beta decay is associated with a neutrino emission, antineutrino we call it. If you have 2 to 3 neutrino, we have 6 times more antineutrinos. And in fact, the gentleman who got Nobel Prize in 1985, it is from the reactors only. But we did not do, because our motivation was to do nuclear fission and energy production. But today we are measuring it. BRC, some colleagues, maybe elsewhere, they are trying to set off, because it is something you don't go to near the reactor. neutrino can come out. Sit outside, 1 kilometer, 2 kilometer, put your detector and detect. And this is something we have missed it, but India should think to do detect neutrino, because if we have to go to 100 gigawatt, imagine how many reactors will have been. And if so many reactors, 100 gigawatt, there will be plenty of neutrino. Measure sitting in your own place. Only you have to have right big detectors. So this is one science India is continuing, will do to continue so. Having done so much, what has happened is, this is the pie chart of the dark universe. We are proud, we say we are very intelligent, we know everything. We are talking about, you ask young generation, you will be feeling shame knowing their knowledge. But I will tell you that they are knowledgeable only 5%. Because what we know today, only 4% of the visible universe. 96% is invisible, we do not know what it is. And out of that, 0.1 to 2% neutrinos I told about. It is a big messenger for the future. Maybe it is telling something big about science. To detect that, you need a big technology. So that will move in its own way. Department of Atomic Energy also, apart from technology, nuclear power production, basic research also continues. This is part of that. 23% is dark matter. We don't know what is that. They are there because they are massive. They are affected by the gravity, but they don't interact. So they are dark matter, and they are dark energy, 73%. So 4% or around that, if you leave about, 96 or 95% is dark, either in matter or energy. We do not know it. So this is the science. Future science in this field will be taking a stand that way. Well, not only that, and now we believe that science in the space, universe is full of everything what we are doing in the earth, probably universe has gone that phases. Big Bang started, expanding, galaxies are there. And today, whatever I'm talking about, neutrinos, dark matter, dark energy, probably it is all part of the big universe. So studying the universe is a phenomenon now. You have to build detectors such a way you study the deep universe. And how you will study it? By various signals. And signals, what you say, these are all electromagnetic in nature. Only frequency is different. If you see the entire electromagnetic nature, maybe it will be radio wave, microwave, infrared, visible, ultraviolet, X-rays, and gamma rays. That's all. And you put the detectors now and look at the sky. Now you don't have to go anywhere. Or science is not there in the earth. Either you have to look space or go underground. On the ground you will not see it. Underground you want to go because background will be eliminated. Go down and down, and you will see the rare signal will see. So time has come, we go up or go down. On the surface, science will be there, but difficult. This time, which I am talking about, will be difficult to measure. You know that our TFR colleagues at Pune, they have a giant meter wave radio telescope. They concentrate on the radio waves, and one of the famous facilities in globally. A lot of people come. I'm only listing where I told sun experiment outside, but these are the something which all should be proud of. It is in India, and it is strongly supported by Department of Atomic Energy. Gravitational giant meter wave radio telescope, working very well. It is upgrading, and its counterpart square kilometer array is a part of that. Chandra telescope at Hanle, it is by IIA, Indian Astronomy, Department of Indian Astrophysics and Astronomy. They have a telescope or visible region, infrared and visible. They have a 2-meter telescope. There we have set up a telescope to look Cherenkov radiation coming from very high energy gamma rays. Once it comes to the atmosphere, it will convert into the Cherenkov visible light, and we are detecting. This is called mesh telescope, and I'm telling you this is the largest telescope in Asia, 21-meter diameter, and probably the largest telescope in world working. And this is what last year it was installed, inaugurated. And it is there, this facility, completely indigenous, made by BRC ECIL, and future. Seeing this, international community is coming, because Hanle is a place, it is around 5 kilometers from the sea level, and it is one of the, in this measurement, it is the largest altitude globally. It's the best place. Right? So it is attracting people. So this will give the gamma ray astronomy. Chandra, I told you a little before, it is infrared astronomy. GMRT, radio wave astronomy. LIGO, there is another wave called gravitational wave, where these huge galaxies, dark matter, etc. collide. There is a gravity waves. And also we are putting a detector called Larger Interferometric Gravitational Observatory at Hingoli. It will be 2 are in USA and the third leg is here. So with the 3, you will be able to do the triangulation in the sky, pinpointing where the signal would have come. And reactor measurement site for antineutrino. And there is a laboratory in Jadugoda uranium mine. It is a 500 meter. This is the only working deepest underground laboratory in India. And there is a possibility to go to 900 meter. Mining is happening, mining over. Again, these people can go to that ground. And I'm happy to know some indication of dark matter ruling out that this region you don't get dark matter. Such an experiment has been conducted here and it is also published. So these are a few examples of mega science projects. We are doing it. So this is what I thought I'll share with you. I did not say anything as a department in other areas. What we do? We do for national security. We do food security, food preservation using radiation. We do health security. All Tata Memorial Centers, what you are seeing, 11 of them belong to Department of Atomic Energy. In fact, wherever I go, Tata Memorial people say that we belong to Department of Atomic Energy. I say Tata Memorial Center is also belong to Department of Atomic Energy. So this is the proud we take it. There the pride, not only national, international pride. Our institute, like NFC, everything is a one in all, one group, everything happens. AMD, they can say what earth is, which is hiding from the us. They can do all technique. They say where is uranium, where is rare earth. You know what is rare earth? It is something very different. We have a rare earth, Indian Rare Earth Limited. We did long back because we are searching thorium. But today we found that rare earth. We are probably the master in that. And you must have heard rare earth. You know where you find? You find beach sand mineral it is called. And it is so valuable. Today everybody talking about critical minerals and rare earth. And if you are rich with rare earth, you are strategically important. And India is full of that. First is of course China, we are third position. Vietnam, but then we have a rich resource of rare earth. Today they are more valuable than gold and silver. And I was jokingly telling when that Muhammad Ghari attacked Somnath temple 17 times. He took a lot of jewelry and gold and silver. That time if he was knowing about rare earth, probably he would not have gone there. He would have gone to the Odisha beach and the sand he would have collected, war could have been avoided. This is such a important material we are having, and I'm proud that it is Indian Rare Earth Limited, which belongs to Department of Atomic Energy. So there are many such things. Variable energy cyclotron center. There I told that cyclotron medical application to produce these nuclear medicines. We can buy it in India anywhere. See, it is a bought machine. But probably end of this year or early next year, they will be launching indigenous medical cyclotron. And directly shooting here. And ECIL, great adopter of technology, probably adopting this, and if God is in your favor, you will be marketing it also. A unique monopoly business in India for you. Take my word. Bhabha Atomic Research Center, colleagues are there, Malse and Aradhana. What to tell? It's a mother of all units what you see. Tata Institute of Fundamental Research, Bhabha started that first in 45. Basic research, then he said, research from lab to land, it should translate. Bhabha Atomic Research Center is created. And we do everything. We work for ISRO also, antenna, everything. Little jokingly, don't feel bad, I tell one word I have repeated in BRC many times. Today, Department of Atomic Energy in its 70 years journey, probably doing everything, almost everything. Probably, we have not sent a satellite to the moon. Otherwise, we do everything, it is true. We work with ISRO. So what more to tell? I think I should stop here. And thank you very much for your wasting your time. And telling some slides, it is basically collection from the museum. And it befitting that I'm giving this talk under the roof of a great museum. Thank you, madam, establish such a museum. Thank you.
Thank you, sir, for the truly inspiring discourse on the subatomic and fundamental particles and its application in developing technologies that facilitates better livelihood for the common public. The lecture was truly exceptional, illuminating the connections between cosmic discoveries and technological advancements. Before we proceed, we like to give our audience the opportunity to engage directly with our chief guest. May I request the audience to please come forward and pose a couple of focused questions to Dr. Ajit Kumar Mohanty, sir, on his topic today. Is there any questions from the audience? Mic. Sir, mic.
Kind of experiments which are being thought, and then what kind of detectors and what kind of theories which are available as far as finding out dark matter, and of course understanding the behavior of dark energy, the universe are concerned, and how space-based systems can also help in that.
See, it is a very good question. Dark matter, there are many speculations which comprising of dark matter. People say it itself is a dark matter which can annihilate into gamma rays, but some people that there are many neutrinos are there, massive neutrinos in the universe. They can also part of the dark matter. So it may not be single dark matter, although people are searching for it. If it is existing, it is moving very slowly. It will have a Newtonian movements, and it should be able to detect in a detector by recoil. And from the recoil energy and going to the temperature much below the around the cryogenic temperature where noise is not there, probably will be able to see this recoil. This is one group of people are doing, and this experiment which I referred in Jadugoda by the SINP group, they've used a liquid detector, light hydrogen-based liquid. If there is a dark matter, it can bubble. So it is a bubble detector, and from that they are concluding, so they can detect if the mass is very small. Basically, it is a rule-out region. Nobody has detected this. In this region, it is not there. All the fundamental discoveries are ruling out the region, and in that direction they've done. But space, which I was thinking, that if it is existing, it is better to do some experiment in the space. NASA has done. Can we have a space shuttle station in future and put detectors there? And if it is available in the space, you will see them also, you will be able to detect it.
Yeah, since India is planning to have the Bharatiya Antariksh Station, and that station will be available maybe some kind.
Talked to some of my colleagues in the Bharatiya Antariksh. Can we think of putting some detector, not only dark matter, but there will be many signals which may not be created otherwise. So naturally God has created, universe is expanding, so we need to experiment there.
Okay.
And it should be done, but NASA has already done one, and India should
Can plan.
plan.
Thank you. Thank you.
Sir, I have, I'm Krishna Kumar. I'm CVO ECL. The first question.
Question is mv square by r principle. If the energy is more, radius has to be, it has to be content. So you have to have, otherwise you cannot bend it. So when the energy moves, you have to bend. Then your curvature has to be very large. So 27. When people are telling 100 kilometers next one, when they want to go to the higher energy. So it is there. Cyclotron is small one. Like synchrotron in RRK, it is one. Then the one they are planning will be 1 kilometer, close to that. So more the energy, more the, it is easier to bend. So the bigger circumference. And before Big Bang, there is a gray area. How it was created, we call it Big Bang, but nobody knows T is equal to 0 what it was. There are many theories, inflation, theory of inflation, etc. But I am not an expert, nor people know. Definitely I don't know, but I don't think it is very clear to the researchers as well.
Thank you, sir.
What is the unification theory? We say that weak forces, strong forces, electromagnetic forces, and gravitational forces put together one theory is there. They are trying
Can you
scientists-
repeat again?
Unification theory.
How unification theory, I told you now, all these forces unite into one force. That is what they call at the ground, at a scale, Planck scale they call it. Maybe few seconds after the Big Bang, when the temperature was very, very high, they call the Planck scale they call it. And that scale probably everything was one. That is the unification, grand unification.
This is called string theory.
No, string theory is something different. They say at that scale, the scale will be, the dimension will be 10. 10 dimensions manifested at that scale. It is not the string theory, but applicable at that region. In that region.
Thank you.
Otherwise, science cannot be explained.
Thank you to our insightful audience for the questions, and a special thank you once again to Dr. Mohanty sir for his time and invaluable insights. Your journey will undoubtedly motivate countless aspiring scientists. We now move to the next significant segment of our ceremony, the felicitation of our chief guest and the presentation of the G.P. Birla Memorial Award. First, it is our duty and privilege to honor our chief guest by gracing this occasion and delivering such a profound lecture. May I humbly request the chairman, Srimati Nirmala Billaji, and Dr. K. Mrutyunjay Reddy sir, director sir, and all other senior dignitaries who joined us for lighting the lamp to please ascend the dais once more for the special felicitation ceremony. So, Dr. Prakash Chauhan sir, please join us, sir. I request all the dignitaries who joined us for the lighting of the lamp to join us again. Now the chief guest, Dr. Mohanty ji, will Now the chief guest, oh, okay, sir. Now the chief guest, Dr. Mohanty ji, will felicitate the chairman of the G.P. Basri, Srimati Nirmala Billaji, with a shawl for making a memorable event. Thank you, respected dignitaries. Now we would like to invite all the staff of Birla Science Center to join us for a group photo.
Science Museum staff, please come for a group photograph.
We'd like to invite the members of the Birla family first to get a group photo, followed by the staff of Birla Science Center. Okay. Yes, sir. I request all the staff from the Birla Science Center to join us for a group photo.
We're getting one chair.
जल्दी कर लो।
We would like to invite Dr. Kapoor sir and the NFC team to join us for a group photograph.
Come close. NFC team. Kindly make it fast again. We have to go to NFC. Over. हाँ नहीं नहीं
I request the audience to wait until the national anthem. Please be seated. Please be seated. We will also have a group photo with the others also. After the vote of thanks and national anthem, please be seated in your places.
Next. 6 to 8.
Vote of thanks and group photo with the audience. Okay. As we draw this memorable event to a close, I would like to extend our deepest gratitude to everyone who made this event a success. We sincerely thank the chairman, Srimati Nirmala Birla ji, for permitting us to organize and host this esteemed program. Our deepest thanks are due to our esteemed chief guest, Dr. Ajit Kumar Mohanty, sir, for graciously accepting our invitation to be with us today and for delivering the inspiring memorial lecture despite his exceptionally busy schedule. Sir, your commitment to national scientific advancement and research has been a beacon for all of us. We must also offer a profound thanks to the staff of NFC, particularly Dr. Komal Kapoor, sir, Chief Executive, Shri G.N. Ganesha, sir, Senior GM, and Shri Naveen Dubey, sir, along with their entire team. Their continuous support was instrumental in successful establishment of the NFC Gallery and in the flawless organization of this event. We would like to extend our heartfelt thanks to the government of Telangana for providing and escorting and support. We would like to thank Dr. Prakash Chauhan, sir, Director of NRSC, for your presence and support. A huge thanks to the Director, Dr. K.M. Reddy, sir, for your guidance and support, and the management and administrative teams of G.P. Basri and all the staffs at the Birla Science Center for all your dedicated services in organizing this event. Last but not least, a huge thanks to all the guests, the media, the organizing team, and for your presence and support. Before we conclude, may I now request the entire gathering to kindly rise and stand in attention for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, everyone. The formal proceedings are now concluded. We request all the dignitaries on the dais to remain for a final group photo immediately. Following the photo session, you are all cordially invited to join us for a high tea on the first floor. So you may join for the group photo. Thank you once again and have a pleasant day. Group photos. After your group photos, the audience may join for a high tea on the first floor.
First floor.
भुवन को देखिए मैडम मैं गाड़ी में रखवा
She came, no? Even if nobody came. Adyan, space Adyan. She came and introduced herself. She took a separate picture.
She took already, no?
Oh, she took.
Okay.
With him only. But she
Would you like to join with them?
No. Hey, go. Go. Let them go. Take a pic. Go.
Go. Like by mistake. Yes, sure. Side on. எங்கே நின்றுட்டுருக்க தனியாக நின்றுட்டுருக்க முடிஞ்சது உன்னோடது అరుస్తుంది ఏయ్ హరి
This memorial award. Pleased to know that it is given by so many Nobel laureates before. Due to that, it is privileged to give this to this best audience.
Yeah. So, sir, to tell us, how was this session of actually having a growth in
See, atomic energy is growing. If you see our motto of the department is atoms for the service of the nation. So although our primary motivation is to have the energy of the nuclear atoms and the nucleus, at the same time we have a lot of application other than power. It applies to health sector, agriculture, food, water, and of course the nuclear power. So, and it is growing. And we expect that we have a very ambitious dream that we should have 100 gigawatt by 2027.
If you see in the next 5 years, what is the plan that as chairman you'd like to take ahead of the development that's happening?
Ahead of the development, our immediate plan is to go to the 22 gigawatt nearly by 2052. In parallel, we should also try to utilize thorium. We want to see best reactor to utilize thorium. And there are a couple of R&D projects in this direction, starting from molten salt reactor. And our second stage program itself is going on. Yes. Future will be a mix of first stage, second stage, and third stage of nuclear programs in the country.
The youngsters who are taking studies in atomic energy do a lot of research. What do you have to tell them?
And they are studying it. I don't think that which direction they should say. They should study well. It is not that atomic energy they should keep in their mind. Student, their aim is to learn. They can learn about atomic energy. They can learn about space program. This will be only creating inspiration to their young mind. And what they will be doing, sky is the limitation.
Thank you.
Thank you.
For ANA.
Some question?
Yeah, if you wish to. Okay. So tell us about today's program and how is the development of atomic?
See, today's program was very different. I wanted to give a memorial award. And this memorial award, I'm very fortunate to have it because my predecessors of this award are very, very significant personalities, including Nobel laureates. Even Abdul Kalam also has given the talk. So in that respect, if I say, I'm highly honored and privileged. And I gave a talk. It is a very generic talk. I talked about a discovery which was made in 2012, also related to Higgs boson, and a very important discovery where India participated. And there are two major experiments in this contest, Alice and CMS. It is at SAR. Around both the experiment, close to 100 people are participating in this experiment. They made this experiment successful, for which Nobel Prize went to Peter Higgs and Francois Anglet in 2013. And my talk was all about that.
Okay. So the program today, what do you have to say about this program today?
This is a wonderful program, and I could see a lot of participants from the academia as well as from school colleges. It is very informative, and I am amazed that this such type of program is going on behalf of this museum. And thanks to the Birla family, Madam Birla came personally, and at the age of 90 plus, and she could sit there for so many hours. I'm really amazed. She and her aunt, Maushi, she is 2 years elder than her. Even then they both are sitting here. So this shows the passion for science by them also. And, these are really very touchy.
Thank you.
Thank you so much.
Evening was speech.
Big birthday. Yeah, 1 second. Yeah. Yeah. So today Nirmala ji was here and she was also doing a lot of things for development and at this age. What do you have to say?
I am amazed with the Madam Nirmala Birla because I am amazed because I am amazed with Madam Birla because not only I was supposed to come on 18th, I could not come because of other preoccupation, but I delayed my coming here. She also delayed her going back to Calcutta. This shows her passion for science. At the age of 90 plus, she is sitting and listening my talk, along with her Maushi. And it shows that her dedication not only for this education, toward the education of science for the people, but her own interest for science and sitting all across my lectures. Great. great lady.
Just now you told about the research that happened. Can you put some light on that? 2 experiments.
See, these 2 experiments is a fundamental research discovering certain Higgs particle, which is a mechanism by which everything would have got mass. But more than that, what I am telling, these are the part of mega science project, and it has created an opportunity now for the people to do much more experiment, because there are much more to go. And looks like that very little we have understood of the great universe which God has created. And as a human being, we probably have understood 4 to 5% of it. Remaining 95% is known to us. We call it dark matter, dark energy, and we have to learn about them. And probably how many birth will take place to understand, I don't know.
Thank you, sir. Nice. Detailed